Okay, so in the next video we'll continue the problems on vector algebra. In the fourth part we'll see the next problem. So here we are given that the vectors a bar, b bar and c bar expressed like this, and here you are asked to show that these three vectors forms a right angled triangle. This we can verify in two steps. In the first step, we have to show that these three vectors forms a triangle. For that purpose, what we need to do is, if we evaluate the sum of any two vectors, and if the sum of these two vectors works out to be equal to the third vector, then we can say that these three vectors constitutes a triangle. That is the first step. And in the next step, to show that this triangle formed by the three vectors is a right angle triangle, how can we prove this? This can be proved by taking the dot product of any two vectors. If the dot product of any two vectors works out to be equal to 0, then we can say that those two vectors are perpendicular to each other, and hence the triangle formed by these three vectors is a right angle triangle. So this we can prove in two steps. So let us see the first step. So we'll first show that these three triangles forms a triangle. These three vectors forms a triangle. So for that purpose, let us first evaluate the sum of the vectors b bar and c bar. So let us evaluate the sum of the two vectors b bar and c bar. So we have the vector b bar expressed as I cap minus 3j cap plus 5k cap, plus c bar is expressed as 2i cap plus j cap minus 4k cap. So the sum of these two vectors works out to be equal to 1 plus 2 is 3i, minus 3 plus 1 is minus 2j, and 5k minus 4k is k. So b bar plus c bar works out to be equal to 3i cap minus 2j cap plus k cap. And here we observe that this is nothing but the vector e bar. So this is equal to e bar. So what we can say is, since b bar plus c bar works out to be a bar, we can say that this implies that the three vectors a bar, b bar and c bar form a triangle. We can conclude that these three vectors forms a triangle. Now, to show that the triangle formed by these three vectors is a right angle triangle, we have to evaluate the dot products of the two vectors. So let us first evaluate the dot product of a bar and b bar. So what will be the dot product of a bar and b bar? A bar dot b bar is equal to, a bar is 3i cap minus 2j cap plus k cap dot b bar is I cap minus 3j cap plus 5k cap. So this is equal to 3 into 1 is 3, minus 2 into minus 3 is plus 6, and 1 into 5 is 5. So this is 14. So the dot product of vectors a bar and b bar, since is finite, is non-zero, these two vectors are not perpendicular to each other. Then evaluate the dot product of b bar and c bar. B bar dot c bar works out to be equal to I cap minus 3j cap plus 5k cap dot 2i cap plus j cap minus 4k cap. So this is equal to 2 minus 3 minus 20. So this is minus 21. So again, the dot product of the vectors b bar and c bar is not equal to 0. Therefore, the vectors b bar and c bar are also not perpendicular to each other. Then evaluate the dot product of a bar and c bar. So a bar dot c bar works out to be equal to a bar is 3i cap minus 2j cap plus k cap dot c bar is 2i cap plus j cap minus 4k cap. So this is equal to 3 into 2 is 6, minus 2 into plus 1 is minus 2, plus 1 into minus 4 is minus 4. So this works out to be equal to 0. So since the dot product of a bar and c bar works out to be equal to 0, this clearly indicates that the vectors a bar and c bar are mutually perpendicular to each other. So that the triangle formed by these three vectors a bar, b bar and c bar is a right angled triangle. So that is how we can prove that the three given vectors forms a triangle, and the triangle formed by these three vectors is a right angled triangle. Okay. So let us see the next problem. Next is, if a bar is equal to 2i cap minus 3j cap minus k cap, and b bar is equal to I cap plus 4j cap minus 2k cap, you are asked to find, first is a bar cross b bar, secondly b bar cross a bar, and the third is a bar plus b bar cross a bar minus b bar. So you are given the vectors a bar and b bar. A bar is expressed as 2i cap minus 3j cap minus k cap, and b bar is expressed as I cap minus 4j cap minus 2k cap. Then you are asked to evaluate the cross product of a bar and b bar, a bar cross b bar cross a bar, and a bar plus b bar cross a bar minus b bar. So let us evaluate these cross products one by one. So let us first evaluate a bar cross b bar. As we have seen that the cross product of the two vectors, that is 2i cap minus 3j cap minus k cap cross I cap plus 4j cap minus 2k cap, this can be expressed in the form of a determinant. The first row of the determinant is the unit vectors I, j, k. The second row of the determinant is the components of the first vector in the product, that is 2 minus 3 minus 1, and the third row of the determinant is the components of the second vector in the product, that is 1, 4 minus 2. So this determinant, if we evaluate it, we can express it as I cap into bracket 6 plus 4 minus j cap into bracket minus 4 plus 1 plus k cap into bracket 8 plus 3. So this is equal to 10 I cap minus minus will become plus 3 j cap plus 11 k cap. So this is the cross product A bar cross B bar. So let us evaluate B bar cross A bar. B bar cross A bar will be equal to determinant of ijk. The second row will be the components of the first vector in the product, that is 1, 4, minus 2, and the third row will be the components of second vector in the product, that is 2, minus 3, minus 1. So this will work out to be I cap into bracket minus 4 plus 6 minus j cap into bracket minus 1 plus 4 plus k cap into bracket minus 3 minus 8. So this is equal to minus 4 plus 6 is minus I cap into minus 4 minus 6, it should be minus 4 minus 6 is minus 10 I cap minus j cap into minus 3. So this is minus 3 j cap minus 8 minus 3 is minus 11 k cap. So if we take the minus sign common, so we can express it as minus into bracket 10 I cap plus 3 j cap plus 11 k cap. So this is nothing equal to minus of, if we compare A bar cross B bar and B bar cross A bar, we can say that B bar cross A bar is equal to minus of A bar cross B bar. So that is how we can evaluate A bar cross B bar and B bar cross A bar. And from this, what we observe is that A bar cross B bar is equal to minus of B bar cross A bar, or B bar cross A bar is equal to minus of A bar cross B bar. So that is these are the first two identities. Now let us evaluate the third identity, that A bar plus B bar cross A bar minus B bar. So for that purpose, let us evaluate third is A bar plus B bar cross A bar minus B bar. So let us first evaluate A bar plus B bar. A bar plus B bar will be 2 plus 1 is 3 I cap minus 3 plus 4 is plus j cap minus 1 minus 2 is minus 3 k cap. This is A bar plus B bar. And what will be A bar minus B bar? A bar minus B bar will be 2 minus 1 is 1, that is I cap, minus 3 minus 4 is minus 7 j cap, minus 1 minus of minus 2 is plus 2, so it is minus k cap. So this is A bar minus B bar. And now we can evaluate A bar plus B bar cross A bar minus B bar. So this is equal to determinant I, J, K. Second row is the components of the first vector in the product, that is of A bar plus B bar is 3, 1, minus 3. And the third row is the components of second vector in the product, that is of A bar minus B bar is 1, minus 7, minus 1. So this is equal to I cap into bracket minus 1 minus 21 minus j cap into bracket minus 3 plus 3 plus k cap into bracket minus 21 minus 1. So this is equal to minus 1 minus 21 is minus 22 I cap. Minus 3 plus 3 is 0. So it's plus 0 j cap. Minus 21 minus 1 is minus 22 minus 22 k cap. Or this is nothing but v bar plus v bar, and that is minus 20. Okay, this plus, it should be plus here, should be plus k bar, so this is plus 1 here. So I cap into 1 minus 21, j cap is 3 plus 3 and k cap into bracket minus 21 minus 1. Okay, so this works out to be equal to plus 1 minus 21 is minus 20, 3 plus 3 is 6, so it should be minus 6 j cap and minus 21 k cap. So this is the cross product of a bar plus b bar and a bar minus b bar. So this again also can be proved by another method. So let us see the alternative method to evaluate the cross product of a bar plus b bar and a bar minus b bar. So we have a bar plus b bar cross a bar minus b bar can be expressed as, by taking the product, we can express it as a bar cross a bar minus a bar cross b bar plus b bar cross a bar minus b bar cross b bar. So this is how we can express. So here a bar cross a bar and b bar cross b bar is 0. So this is nothing but minus a bar cross b bar plus b bar cross a bar. So as we know that b bar cross a bar is nothing but minus of a bar cross b bar. So this is equal to minus twice a bar cross b bar. So this is nothing but minus twice a bar cross b bar. And if we use the expression for a bar cross b bar that we have all obtained earlier, so a bar cross b bar is equal to 10 I cap plus 3 j cap minus 11 k cap. So this is equal to minus 20 I cap minus 6 j cap minus 22 k cap. So either we can first obtain the sum of the vectors a bar and b bar and subtraction of vectors a bar and b bar and then take the cross product, or else by evaluating this cross product like this, we observe that in both ways the result that we get for a bar plus b bar cross a bar minus b bar is one and the same. So that is how we can evaluate these cross products. So let us see the next problem. if A bar, B bar and C bar are three vectors such that A bar plus B bar plus C bar is equal to 0. Prove that. We are asked to prove that A bar cross B bar is equal to B bar cross C bar is equal to C bar cross E bar. So we have to prove this identity. You are given that these three vectors are such that the sum of the three vectors A bar, B bar and C bar is equal to 0. And if it is so, then you are asked to prove that A bar cross B bar equal to B bar cross C bar is equal to C bar cross E bar. So since we are given that A bar plus B bar plus C bar is equal to 0, this clearly indicates that or implies that the vector C bar can be expressed as minus of A bar plus B bar. C bar is equal to minus of A bar plus B bar. And using this expression for C bar here, we can evaluate these three cross products. So let us first evaluate B bar cross C bar. What will be B bar cross C bar? B bar cross C bar is nothing but B bar cross C bar can be replaced by this minus of A bar plus B bar. So this is equal to minus into bracket A bar plus B bar. So this is equal to minus of B bar cross E bar minus of B bar cross B bar. So B bar cross B bar is 0 and minus of B bar cross A bar is nothing but A bar cross B bar. Minus of B bar cross A bar is nothing but A bar cross B bar. So we have proved this first part of the identity, that B bar cross A bar is equal to A bar cross B bar. Then let us see the next part of the identity, that evaluate C bar cross A bar. So this C bar is to be replaced by this. So it is minus of A bar plus B bar cross E bar. So this is equal to minus A bar cross A bar minus B bar cross A bar. So A bar cross A bar is 0 and this is nothing but minus B bar cross A bar, and minus B bar cross A bar is nothing but equal to plus A bar cross B bar. So what we observe is C bar cross A bar is equal to A bar cross B bar. So in the first identity we observe that B bar cross C bar is equal to A bar cross B bar, and in the second identity we observe that C bar cross A bar is equal to A bar cross B bar. So what we can say is that therefore we can conclude that A bar cross B bar is equal to B bar cross C bar is equal to C bar cross A bar. So that is what we can conclude here. So if these three vectors, the sum of the three vectors is equal to 0, then we arrive at the conclusion that the cross product of A bar and B bar, the cross product of B bar and C bar, and the cross product of C bar and D bar is equal. So that is the next identity. Then let us see the next problem. we are given the three vectors defined as E bar equal to 2i cap plus 3j cap plus 5k cap. B bar is equal to I cap plus j cap plus k cap, and C bar is equal to 2i cap plus j cap plus 3k cap. And we are asked to show that A bar dot B bar plus C bar is equal to B bar dot C bar cross E bar is equal to C bar dot E bar cross B bar. This is in accordance with the scalar triple product of the three vectors A bar, B bar and C bar. So let us evaluate this scalar triple product, this scalar triple product and this scalar triple product separately. So let us first evaluate A bar dot B bar cross C bar. We have seen that the scalar triple product of these three vectors is nothing but equal to the determinant of the coefficients of the three given vectors. The first row of the determinant is the components of the first vector in the product ax, ay, az. Second row is the components of the second vector in the product, that is bx, by, bz, and the third row is the components of the third vector in the product, that is cx, cy, cz. So this works out to be equal to determinant of ax, ay, az are 2, 3, 5, bx, by, bz are 1, 1, 1, and cx, cy, cz are 2, 1, 3. So this is equal to 2 into bracket 3 minus 1 minus 3 into bracket 3 minus 2 plus 5 into bracket 1 minus 2. So this is equal to 3 minus 1 is 2 into 2 is 4 minus 3 minus 2 is 1 is 3 plus minus 1 minus 2 is minus 1 into 5 is minus 5. So this is equal to 4 minus 3 minus 3 minus 5 is minus 8 plus 4 is minus 4. So this scalar triple product works out to be equal to minus 4. So first scalar triple product works out to be equal to minus 4. Then let us evaluate the second scalar triple product, that is B bar dot C bar cross E bar. So this is expressed as the determinant of bx, by, bz, that is 1, 1, 1. Cx, cy, cz 2, 1, 3, and ax, ay, az 2, 3, 5. So this is equal to 1 into bracket 5 minus 9 minus 1 into bracket 10 minus 6 plus 1 into bracket 6 minus 3, 6 minus 3. So this is equal to 5 minus 9 is minus 4, 10 minus 6 is 4, so it is minus 4, and 6 minus 2 is 4 into 1 is plus 4, so this is equal to plus 4. Sorry, it should be minus 4. Minus 4. And let us evaluate the third scalar triple product, C bar dot A bar cross B bar. So this is equal to determinant Cx, Cy, Cz is 2, 1, 3, Ax, Ay, Az is 2, 3, 5, and Bx, By, Bz is 1, 1, 1. So this is equal to 2 into bracket 3 minus 5 minus 1 into bracket 2 minus 5 plus 3 into bracket 2 minus 3. So this is equal to 3 minus 5 is minus 2 into 2 is minus 4. 2 minus 5 is minus 3. Minus 3 into minus 1 is plus 3. And 2 minus 3 is minus 1 into 3 is minus 3. So this is equal to minus 4. So here what do we observe is that A bar dot B bar cross C bar, B bar dot C bar cross C bar, and C bar dot A bar cross B bar, every time the scalar triple product works out to be equal to minus 4. And hence what we can see is that these three scalar triple products are equal. So that is how we can prove this. Okay, next. So that the given three vectors, A bar equal to 2 I cap minus j cap minus k cap, B bar equal to I cap plus 2 j cap minus 3 k cap, and C bar equal to 3 I cap plus 2 j cap minus 5 k cap are coplanar. We are asked to show that these three vectors A bar, B bar and C bar are coplanar. We have said that while discussing the geometrical interpretation of the scalar triple product, that the scalar triple product of the three vectors gives us the volume of a parallel pipette formed by the three vectors as the three adjacent edges. So if these three vectors lie in the same plane, then the height of the parallel pipette will be equal to 0, so that the volume of that parallel pipette will work out to be equal to 0. So if we evaluate the scalar triple product of these three vectors, and if this scalar triple product of A bar, B bar and C bar works out to be equal to 0, then we can say that these three vectors are coplanar. So let us evaluate the scalar triple product of these three vectors as A bar dot B bar cross C bar. So let us evaluate the scalar triple product of these three vectors. And we have seen that this scalar triple product is expressed in the form of determinant of the coefficients of these three vectors. So it is AX, AY, AZ, BX, BY, BZ, CX, CY, CZ. So this is equal to AX, AY, AZ is 2 minus 1 minus 1. BX, BY, BZ is 1, 2 minus 3. And CX, CY, CZ is 3, 2 minus 5. So this is equal to 2 into bracket minus 10 plus 6 minus of minus 1 is plus 1 into bracket minus 5 plus 9 minus 1 into bracket 2 minus 6. So this is equal to Minus 10 plus 6 is minus 4 into 2 is minus 8. Minus 5 plus 9 is plus 4 into 1 is plus 4. 2 minus 6 is minus 4. Minus 4 into minus 1 is plus 4. So minus 8 plus 4 plus 4 is 0. So since the scalar triple product of the three vectors a bar, b bar and c bar is equal to 0, this implies that the vectors a bar, b bar and c bar are coplanar. The three given vectors are coplanar because the scalar triple product of these three vectors work out to be equal to 0. So that is how we can prove that these three vectors lie in the same plane. Okay. And let us see the last problem. One. You are asked to show that a bar cross b bar dot a bar cross b bar is equal to a square b square minus a bar dot b bar bracket square. You are asked to prove that a bar cross b bar dot a bar cross b bar is equal to a square b square minus a bar dot b bar bracket square. So we have the definition of STP, scalar triple product, that the scalar triple product of the three vectors, say x bar dot a bar cross b bar, is expressed as, this is nothing but equal to x bar cross a bar dot b bar. We can change the positions of dot and cross here. By interchanging the positions of dot and cross, we can express this as x bar dot a bar cross b bar is nothing but x bar cross a bar dot b bar. So now this is nothing but equal to, but this, if we replace x bar by a bar cross b bar, so let us now replace x bar by a bar cross b bar, then what we'll get, the left hand side will be a bar cross b bar dot a bar cross b bar, and here if we replace this x bar by a bar cross b bar, it will be a bar cross b bar cross a bar dot b bar. So this vector x bar is replaced by a bar cross b bar. So if we solve this bracket by using the definition of vector triple product, we can express it as empty bracket. If we use the back-cab rule, in accordance with the back-cab rule, the right hand side can be expressed as b bar into bracket a bar dot a bar minus a bar into b bar dot e bar dot b bar. So by using the definition of this vector triple product, this is nothing but the vector triple product, and by using this back-cab rule, we can express this vector triple product like this. So now if we evaluate this product, then we can express it as this is nothing but equal to b bar dot b bar into e bar dot e bar minus e bar dot b bar into b bar dot e bar. So, what is b bar dot b bar? B bar dot b bar is b square, and a bar dot a bar is a square minus a bar dot b bar is equal to b bar dot a bar. So this b bar dot a bar, if is replaced by a bar dot b bar, it is a bar dot b bar into a bar dot b bar. So this is nothing but a bar dot b bar bracket square. So what we arrive here is a bar cross b bar dot a bar cross b bar works out to be equal to a square b square minus a bar dot b bar bracket square. So that is how we can prove this identity, and with that we close the problems on this chapter on vector algebra, and in the next video we'll continue with the next chapter.